Hello everyone, welcome to an algebra video tutorial learning about exponential functions and word problems. So I wanted to do a first word problem based off percent change and thinking about how we can take something where we're either growing by a percent or decreasing by a percent and model that change using an exponential function to help predict out further what the change is going to happen. So here we go. We're going to do percent change, specifically inflation rates. So here's our problem. We have a gallon of milk costs approximately $3.49 at the grocery store. Using the chart and assuming an inflation rate of 3.22% over the next 20 years, how much will a gallon of milk cost 20 years from now? So here's a chart. I like this one. I found it online. It just shows the average annual inflation each decade. And again, inflation just tells you how much did the price of things increase, or how much was the value of a dollar over that time period. And so you can see there's periods where things increased by a lot. There's times where it actually decreased. And there's times where it increases a little bit. But on average, you can see that if we take the last 100 years approximately, in general, things increase in price by about 3.22% every year. So here we go, that's a percent change. When we do percents means we multiply, which means we have an exponential function here. All right, so an exponential function. Let's kind of review what we have here. Every exponential function, f of x, we can write it as my starting value, a, times some value b we're multiplying by to the x power. X is our independent variable. It's in the exponent, which makes it an exponential function. And b is just what we're multiplying by over and over and over again. So let's interpret this problem now and translate this into some math we can use. Right now we know a gallon of milk costs $3.49. That's our starting value. That's what we're going to put in for a. So a is always what we're starting with. We're starting with some value, and then we're multiplying after that from there. So in this case, in our specific problem, it's $3.49. That's right now what a gallon of milk is and what we're basing it off of. Now, we're assuming an inflation rate of 3.22%, which means it's a growth, which means my multiplier b, that's my base, and what I'm multiplying by. In our case, it's growing by 3.22%. That's how we interpret inflation. So it's 1. 1 is what I multiply to stay the same, but I'm growing from that 3.22%. I have to turn that into a decimal equivalent, so it's 0.0322. So that plus part is my increase of 3.22%. We put 0.0322 because I take the 3.22%, which is out of 100, and I just divide it by 100 to turn it into its decimal. So we've got our starting value, we've got our base, and we also know that in our x variable, we're asked to specifically find in 20 years, which means 20 years of increasing by this 3.22% each year. 3.22% we're increasing. So I want to do that for 20 years, which means I'm going to multiply by that 1.0322 20 times. All right, let's calculate it out. Let's do some math here now. So in my function, we're going to input 20 in for x after 20 years. I'm starting with $3.49. We're going to multiply it by 1.0322. There's my increase of 3.22%. We're going to do it for 20 years. Now if I calculate all that out using my calculator here, we come up with that it equals 6.57813, which is a nice decimal. But we're understanding we want to know how much will a gallon of milk cost, so I want to round it to the nearest cent. I'm going to do 6.5 There we go. In 20 years, we can expect, if we pay about $3.49 now for a gallon of milk, in 20 years, we can expect to pay about $6.58. That's quite a lot of difference. It's almost double, right? Not quite double, but it's a big increase. So there we go. We just used exponential functions to model inflation, to use some real data, to model some trends that we see happening in the United States, and be able to make a prediction for the price of a gallon of milk 20 years from now.